All right, part 2 for lesson 1, characteristics of functions. So in the previous video, we were talking about functions, and we were talking about the different ways functions can be described. We talked about input-output functions, or input-output tables. We talked about graphs. We talked about equations. And in fact, we left off with taking a function, f of x equals x squared minus 3, and evaluating this function at several values and then plotting those points. So here we have an algebraic description of a function. We have the table of values, which is the numeric description, numerical description, and here we actually have a graphical or visual description of the function. So this function has been modeled 3 different ways. The only thing that hasn't been used to describe this function is the verbal description. And so we'll get to those kinds of things a little later, but we're going to look at a variety of different characteristics of functions and tie some things in together. So I'm going to set this aside for just a second, and let's pull up the next page. I think this might be page 3 of your notes. So there's several things that we are going to begin identifying from the graph of a function: the domain, the range, a local maximum, local minimum, increasing intervals, decreasing intervals. We're going to talk about what does it mean for a function to be an even function, what does it mean for a function to be an odd function. So looking at this particular example, this graph that I've provided, actually, I'm going to do this. I want to pull my last example back into view for just a minute. So we took this particular function, f of x equals x squared minus 3, and we created some points, and we graphed those points, and then we drew a curve to fit those points. When you look at this graph, when you look at a graph left to right, there are several things that we can identify from this graph. Okay, and that is, we can identify the domain. Now, the domain is the set of input values. And when we look at this, we only used, 6 values? 1, 2, 3, 4, 5, 6, actually 7, I'm sorry. We only found 7 particular points for this function. But those 7 points are not the only points that belong to this function. When you look at this graph and you're wanting to determine the domain, in other words, what x values belongs to this function, look at it, look at the graph left to right, and then ask yourself, what is the smallest value? What is the smallest x value that is included in this graph? Well, if you're looking at it from this perspective, how far does the left go? How far to the left does the graph go? Well, when you look at this graph, if you're looking at it here, even though it's going up, it's also going outward. So the smallest value would be negative infinity, and the largest value, as you travel along this graph, your x's are getting bigger and bigger and bigger and bigger, and they will continue to get bigger. So the domain for this function is negative infinity to positive infinity. Now I'm going to write this using interval notation. And interval notation uses parentheses and brackets. And I'll emphasize that as we go along. But infinity and negative infinity always gets parentheses. You will never use a bracket around infinity or negative infinity. So let's talk about the range. your range is your set of output values or your Y values. So when you look at this graph, if you look at this graph, what is the smallest Y value? The smallest Y value is that value right there, and that is at -3. So your smallest value is -3. What is the largest Y value? What's the largest Y value? Well, because the graph has the arrows at the ends, which indicate that there are an infinite number of points on this graph, then the largest would be described as infinity. So we're going to put parentheses around the infinity, but let's talk about the range in the -3. Since -3 is included in the Y values, then we're going to put the -3 in a bracket. The other thing we might identify from a graph is where does the graph increase and where does the graph decrease? So looking at your graph left to right, this particular graph is decreasing starting at, let me write that out, decreasing starting at -infinity, and it stops decreasing when x equals 0. So decreases from -infinity until it reaches 0. At 0, the graph then begins to increase. So I'm going to kind of fill this out, both of these out at the same time. Oops, hang on, we're going to talk about that in just a second. So at 0, when x is 0, the graph of this function begins to increase. And from x equals 0, the graph will increase forever. So that would be from 0 to infinity, which I know infinity is going to get parentheses. Now, at the point x equals 0, at that point right there, the graph is neither increasing nor decreasing. So this is when we're going to use parentheses around 0. Increasing and decreasing will never have brackets. And then one other thing I might point out with this particular graph is this point right here, which you guys probably would refer to that as the vertex of the parabola. We can also say that that is a local minimum, if I can spell. Local minimum. This is a local minimum. And it's a local minimum because the graph changes from decreasing to increasing at 0. So those are just a few things that we're going to emphasize as we go through looking at some examples of functions and identifying certain things. All right, so now I'm going to go back to the graph that I've provided here, and I haven't done a very good job of this particular graph doesn't have numbers, and that's okay, but I just want us to look at how do we identify the domain. Well, this particular graph has arrows at each end. So that means the graph continues in the -x direction as well as the -y direction. It just continues downward and to the left. The arrow at this right end behavior is going to tell us that the graph is going to continue with this behavior infinitely in the positive x direction. The range would be the set of y's. So your range would represent the values from the lowest y to the largest y. Well, this particular function's arrow is pointing downward. So this graph is going to continue downward. So for the range, that would be -infinity. But if you look at this portion of the graph, this is going to be the highest value of the graph. So this particular y value, whatever it is, would be the highest or the largest y value. All right, does this, just looking at the graph, does this graph have a local maximum? A local maximum is going to occur at a point where the graph changes from increasing to decreasing. So this point right here is going to be a local maximum. And again, it's a local maximum because this graph is changing from increasing to decreasing here. A local minimum occurs where at a point where the graph changes from decreasing to increasing. So this point right here is a local minimum. And if we're talking about increasing intervals, intervals are always x values. But if we just simply look at this graph, we notice that, and we've kind of already emphasized this, but the function is increasing here. The function is increasing on this portion. The function is decreasing or falling. And then one of the other things that I haven't necessarily included is that this portion right here, this particular portion of the graph is not increasing, it is not decreasing, it is remaining constant. So that's another piece of information that would be that we might be interested in also, even though I don't have it listed here. So increasing intervals are going to occur where the function is rising, and you always, again, look at a graph left to right. So the graph is rising, then the graph is falling, the graph is rising, and the graph is remaining constant. So the other thing we're going to talk about is what makes a function be considered an even function. Well, even functions and odd functions have to do with symmetry. Functions that have symmetry with respect to the y-axis is going to be an even function, kind of like, and I'm going to pull this in, this particular function that we worked with earlier and yet in the previous example. This particular graph has symmetry about the y-axis, meaning if I folded this graph over, then this part of the graph would lie directly on top of that part of the graph. So that means that this function right here is an even function. So when we talk about even and odd functions, we're talking about symmetry. An odd function will be a function that has symmetry with respect to the origin. So that's what it means. That's what we're talking about when we talk about symmetry, or when we're talking about even and odd functions. All right, so now let's take that same graph and let's just go ahead and identify some of the things that we wanted to identify. And let's just say that all of these, the x-axis is marked by ones, and we're going to give the y-axis, I don't know, we'll do -3, and we'll say that this is +3. So let's go ahead and identify the domain and the range. So the domain, remember, is the values of x, or the values of x's that belong to this function. And this function continues in the negative x direction infinitely. It also, kind of lost my part of my graph there on the right. And it continues infinitely in the positive x direction. So our domain is going to be -infinity to +infinity. And infinity always gets parentheses. The range of this function, what is the lowest or smallest y value? Since this arrow is pointing downward, then we know the smallest y value would be -infinity. And the largest, because the graph never goes past a y value of 3, that means the range's largest value is 3. Okay, so the smallest y value is negative infinity. Even though negative infinity is not a number, that simply describes the behavior of the y values. We put parentheses around infinity, and then because 3 is the absolute largest y value, we will close that with a bracket. So a bracket says that value is included in the set of numbers. All right, so now let's talk about the intervals for which f is increasing. So looking at this portion of the graph is increasing on this portion. Okay, what is the smallest x value included in this portion of the graph? Well, that would be negative infinity. This portion of the graph stops increasing at this x value, which is negative 1, negative 2, negative 3. So this portion of the graph increases from negative infinity to negative 3. I will close that with parentheses. The function then begins to decrease on this portion of the graph. So this particular, I'm going to do this piece as well at the same time. So this portion of the graph decreases beginning at negative 3 and stopping or stops decreasing at positive 1, and I will close that with parentheses. Then at positive 1, the function or graph begins to increase again, and from 1 until 2, 3, 4. So it increases from 1 to 4. And then what I'll do is I want us to add this. I'm going to draw a little line there. I want to know, where does this function, on what intervals is this function constant? And this particular function is constant beginning with 4 and continues being constant to the x value of infinity. So this particular function increases from negative infinity to negative 3. At negative 3, it begins to decrease and stops decreasing at x equals 1. At x equals 1, the function begins to increase again until it reaches 4, an x value of 4, and then the function continues to be constant beginning at 4 to infinity. Okay, so increasing and decreasing always uses parentheses, because at a point the function is not increasing or decreasing. That's where the graph is changing direction. So it's changing from increasing to decreasing and decreasing to increasing. So the point can't be included for both. And so we just always use parentheses. Okay, so there's another thing I want us to identify that I didn't really talk about up here, but what do you suppose this right here is asking for? It says the intervals for which f of x is greater than 0. Well, when you're looking at a graph and we're talking about where the function is greater than 0, then we're looking for the portion of the graph where the y values are greater than 0. So that would be on this portion. So the graph is below the x-axis on this portion. At this x-intercept, the graph goes from being, the y values go from being less than 0, negative, to greater than 0, positive. Then at this x-intercept, the graph then goes back to being below the x-axis, so your y values are negative. Your y values are negative. then at this x-intercept, the graph goes back to being above the x-axis, which means your y values are positive. So your y values are positive on these two portions of the graph. So how do you state that? So again, an interval is always x values. So the interval for which the y values are greater than 0 begin at this x value. And it's not a really nice, friendly x value, so we're going to name it 4.25. We'll say that that's negative 4.25. So the function is above the x-axis where the y values are greater than 0 at negative 4.25, comma, this point, right, this x-intercept here is at negative 1. So the interval for which the function is greater than 0, the y values are greater than 0, from negative 4.25 to negative 1, then again from 3 to infinity. Because this portion of the graph continues being constant to infinity. And therefore the y values are greater than 0. All right, so now for what intervals, the intervals for which f of x is less than 0 wants us to identify where the y values are less than 0. So now if we look at this graph, this portion of the graph, the y values are less than 0, and the y values are less than 0 or negative on this portion of the graph. So on what intervals is f of x less than 0? That would be negative infinity to whatever that x-intercept is. So it would be negative infinity to negative 4.25. And then from negative 1 to positive 3. And so those are your intervals for which f of x is less than 0. So when you see f of x is less than 0, you need to think of it in terms of where are the y values less than 0. And when we talk about y values being less than 0, we're talking about where are the y values negative. So being able to read and analyze a graph and identify these pieces of information or these characteristics is an extremely useful tool in mathematics. All right, so let's go ahead and continue with these things. Same types of characteristics, but with another graph. And I apologize if the numbers here are a little hard to read, but anyway, let's go ahead and jump right on into this. Okay, I want you to first notice there's one slight difference in this graph from the one that we had previously. Of course, I've written all and drawn all over this graph, but notice that this graph does not have arrows. So this domain and range for this function has a finite set of numbers. So let's talk about the domain. The domain are the values of x that belong to this function. So what is the smallest x value defined in this graph? And that would be negative 10. And the largest is positive 10. Now, for the domain, is negative 10 included? Yes. So we're going to put a bracket. And is positive 10 included? And the answer is yes. So we will use a bracket. So your domain are the x values between negative 10 and 10, including those 2 points. Now let's talk about the range. The range is going to be your set of y values. Well, what is the smallest y value? Well, the smallest y value is negative 4, and negative 4 is included, and the largest y value comes from this point, which is 10. So the range for this function is -4 to +10. Now, what does it mean when, what is this asking us to identify? F of 2. F of 2 wants to know what is the y value when x is 2. So what y value is 2 paired with? So from the graph, I'm going to go over to x equals 2, so 1, 2. The point on the graph is right here. So that point, the y value is 10. So f of 2 equals 10. And not that we need to, but just as a reminder, we could write that information right here as an ordered pair. Okay, what is f of 10? Well, from the graph, go to the point on the graph where x is 10, which is right there. And that y value is 8. So the function, when x is 10, your y value is 8. As an ordered pair, I can write that as 10, 8. And it's not necessary. I'm just trying to remind you that how everything kind of works together. And then f of 0, find the point on the graph where x is 0, which is right here. The y value for that point is 0. Okay. So now let's move over and talk about, does this function have a local maximum and a local minimum? And how do you determine those? Well, you're looking for a local maximum, identify a point or points, there can be more than one, where your graph or the graph changes from increasing to decreasing. So you want to identify the change in the graph from increasing to decreasing for a local maximum, and for a local minimum, the graph needs to change from decreasing to increasing. All right, so let's do that together at the same time. So as I look at my graph left to right, my graph at this point changes from decreasing to increasing. So I have a local minimum, and these are points. These are always points, okay? A single point. It's not an interval, it's a point. So that occurs at -8, minimum -8, -4, and because it's a point, we just use regular old parentheses. Then the graph is increasing until it reaches this point, and this point changes from increasing to decreasing. So this point would be a local maximum. So that point is -2, 6. All right, at that point, the graph changes or begins to decrease until it reaches this point. At that point, it changes to increasing, so that's a local minimum. This was a maximum, this is a minimum. So this minimum has an ordered pair of 0, 0. And continuing on, this point would be a maximum, and its ordered pair is 2, 10. This point would be a minimum, a local minimum at 5, 0. I think that's 5, 0, yeah. Now let's talk about this point right here. This point, and also this point, these two endpoints are neither a local maximum or a local minimum. The reason why is because the graph does not change from increasing to decreasing or increasing to decreasing at those endpoints. There is no change in direction at these two endpoints. So I have 3 local minimums, and I have 2 local maximums. Okay? All right, let's talk about, is f of 4 positive or negative? Now let's talk about what that's asking. This is saying, is the value of f of 4 a positive number or a negative number? So going to the graph, find the point on the graph where x is 4. So 1, 2, 3, 4. So the point where x is 4 is above the x-axis. So that means that the y value of that point is positive. That point, f of 4, is above the x-axis, which means the y value is greater than 0 or positive. Well, how about f of negative 7? If we look at the graph and we find the point on the graph where x is 1, 2, 3, 4, 5, 6, negative 7, that point would be here, and that point, the y value, since the graph or that point is below the x-axis, then f of negative 7, the y value is going to be negative. So when x is negative 7, the point on the graph is below the x-axis, which means the y value is negative. Okay. All right, moving on to identifying the intervals for which the entire function, well, not entire function, but we want to find the y values where the y values are greater than 0. In other words, for this function, on what intervals are the y values greater than 0? So looking at the graph is below the x-axis here. The graph is, I don't want to use that color. The graph is above the x-axis on this portion. The graph is above the x-axis on this portion. And the graph is above the x-axis on this portion. So let's take care of both of these at the same time. So starting left to right, the function f of x is below the x-axis beginning at negative 10. Now at negative 10, think about the y value. The y value of this function at negative 10 is 0. So we can't include the negative 10 as where the function is less than 0. So we have to use parentheses. Then as we move along the graph, then this particular x-intercept is at, what is that at? I can't see it. Negative 5, 1, 2, 3, 4, negative 5. So at negative 5, the x value at negative 5, the y value is equal to 0. And then at negative 5, the graph of the function, the y values become positive. So at negative 5, the function or the y value is equal to 0. So I'm using parentheses. But then it remains, the function does become positive and remains positive until it reaches the x value of 0. So I'm going to close that with parentheses. At 0, the graph remains positive. So I'm going to start another interval at 0, and that particular portion stops being positive at this x value of 5. But at 5, it remains positive until it reaches an x value of 10. So one of the biggest questions is, why couldn't we have written the interval for which f of x is greater than 0 as simply negative 5 to 10? Why couldn't we have written it this way? Well, when you write it this way, you're saying that the graph of this function is above the x-axis, or the y values are greater than 0 at every single x value between negative 5 and 10. But that's not true here, here, or here. So that's why we have to break this apart into 3 separate intervals. Now, I just realized something, and I'm hoping I'm hoping that you did too. There's something that I've done that I've written incorrectly about this interval right here. Notice that the graph at x equals 10, notice that the y value is 8. And that means that 10 at x equals 10, that bracket should be, or that point should be included. So I notice I show that using a bracket. So this function, f of x, is greater than 0. In other words, the y values are positive for the x values -5 to 0, 0 to 5, and then 5 to 10, with 10 being closed with brackets because the point at 10 is above the x-axis. The y value of that point is positive. And the only interval where the y values are less than 0 or negative are between -10 and positive, not positive, but -10 and -5. Okay, so now let's move on and finish this example out by identifying where the function is increasing and where the function is decreasing. So I'll see if we can do this. I've drawn all over my graph. So I'm going to actually get a highlighter out, okay? So this particular graph, the function is decreasing here. The function is increasing, if I can pull this apart. Nope, that's out. Nope. Oh, there we go, sorry. The function is increasing here. The function is decreasing on this portion. It is increasing on this portion, decreasing on this portion, and increasing on this portion. All right, so let's identify the parts or the x values where those changes occur. So let me do this. Okay, so where is f? I'm going to do this all at once. So this graph, left to right, decreases first. So it decreases, I'm going to ignore all of that, decreases and then increases. So it decreases beginning at -10, and it decreases until it reaches, is that -8? -8. At -8, the function increases. So from -8 to -2. At -2, the function decreases again, begins decreasing, and it decreases until it reaches 0. At 0, the function increases again. So 0 to 2, the function is increasing. From 2 to, let's see if I can figure out what that is. That's 0, 1, 2, 3, 4, 5. Okay, so it, no, hold on. So from 2 to 5, the function decreases, and then luckily from 5 to 10, the function increases again. And I do apologize for making that graph a little on the small side and drawing all over it, but drawing on it helps to identify those intervals. So increasing, decreasing, maximum, minimum, those are things that, some characteristics that are things that we find when we're analyzing a graph. Okay, I'm going to conclude this video as part 2, and we'll have a part 3 to this video, or to this lesson, that will wrap up the lesson and its videos.